Okay, Bismillahirrahmanirrahim. Let us go into the last subtopic of our course. Okay, chapter 5.2, solving linear differential equations by method 2, integrating factor. So there is a guideline given in our workbook, but first you have to arrange your equation. Okay, the first order differential equation. Okay, like this format, such that from there you should be able to recognize what is the function p. P here is attached with the y, provided that here we have a single dy dx. So you have to rearrange your equation into this format. So after you have recognized the p, okay, the function p there, okay, by using integrating factor, these are the guidelines. Step number 1, you have to find the integrating factor. The formula of integrating factor, we call it mu, is e power integrating px. So the p is there. Okay. And then after that, you are to multiply both sides of this differential equation with the mu, and you will find that on the left side you can simplify it. It becomes a derivative of mu times y. Okay. And then you bring this dx on the other side, and hence you can integrate both sides in terms of dy and then integrate in terms of dx. Okay, but first, how do we get that integrating factor? Okay, I would like to share with you on how to obtain the integrating factor. So first, again, you have to have that differential equation, okay, in a format or in an arrangement like this. Okay, and then you are to multiply this equation, all terms, with the mu. This is mu. Okay, it's a functions of x. So we multiply mu here and over there and over there. And hence you can see that this looks like mu y prime plus mu times p, which is y. And if you say that this function, this portion, as the mu prime, okay, or the derivative of du on dx, okay, and y, so this looks like a product rule actually. Okay, a product rule. A product rule is when we have the derivative, for example, there we record by a product rule, the derivative of u times y. Okay, the formula of the product rule was u y prime plus y u prime, y u prime, or u prime y. Okay, it's a product rule. So that is why for this portion, if this is u prime, so we can actually combine this. And from, normally we have from here to here. Now from u y prime plus u prime y, we can combine it, that it becomes like this. Okay, as of the right side, we have that u times q. So this u times y there, which was the u y prime plus u prime y. So there we recognize that the u prime is actually this function u times p, a function p just now. Okay. And u prime is actually du on dx. Okay, if you write it down like that. So u together with the du, 1 on u du, and here we have the px dx. Do you see that? Okay. Next, in order to get the u, we integrate both sides. Okay. And then we solve for the integral. The integrating 1 over u du is ln u. Okay. And then here is a function we need to integrate. Okay. So as we solve it, we got ln u and over there. So how to get the u? So again, like we have had earlier, we are to read it as exponent. We introduce e both sides. Okay. like this one, introduce e. Alright, so we know that from the law of the log, e power ln u is actually u, and this factor we write it as e power of this integral px. So that is how we got the integrating factor. Okay, under this discussion on how to integrate the factor, okay, we are to use this later on that I highlighted there. Okay, after you multiply this integrating factor with the p just now, okay, and get this line, you have to be able to combine it into this, okay, into one factor of the derivative of the u multiplied with the y. Right. So let's just look at example on how to apply this. So let us come back to example 3. Okay, in our workbook page 289 just now, we cannot use a method by separating variable. So to use integrating factor, these are the guidelines given. First, we have to recognize what is the integrating factor with this formula. So you do need to rearrange your equation in this format, whereby you can see the p there. So our equation there, okay, dy dx, we have px attached with the y. So in this case, we can easily see or recognize that the p there is cotangent x, right? So then we calculate the integrating factor using the formula e power integrating p. Our p is cotangent x dx. So integrating cotangent x dx, okay, look into your formula list. The answer is ln sine x. Don't put the c, the integrating factor, just yet. So we know that e power ln of this factor is the factor itself using the property of our log. Okay, so we have got the integrating factor, normally denoted by mu, a symbolic mu. It looks like u. Okay, and then after that, step number 2, multiply all sides, all terms with this mu. Okay, so we are to multiply sine x into this equation, right? So we multiply sine x, dy dx, multiply y sine x, cotangent x, and sine x on the right side as well. And then this, as we're rearranging it and simplifying it, okay, here we see cotangent is actually cosine over sine. If I am to simplify, sine cancel off, I am left with cosine xy. Okay, as of the right hand side, we simplify, cosecant is 1 over sine, we get 1. And here, it looks something that is familiar. It's actually a product rule, okay, such that if the u or the f, we want to call it u or f, u is sine and the v is the y, so it becomes u, okay, u v prime or y prime plus u prime, the derivative of v sine is cosine, and v, which is the y just now. So this notation, we can combine it, okay, using the product rule. From this, now we go to this. Okay. So again, this notation, we can combine it such that it becomes u. The u is the sine, okay, sine value, sine x, and the v is the y, okay, the v is the y. So we combine it, right? And as a result of that, as we rearrange, it becomes d of this function multiply dx times 1, which is dx. And then you can integrate both sides to get your y sine x. So then we continue from here to here. Integrate both sides. Okay, we integrate both sides. So we do know that, let's say you are to integrate dv. The integral of 1 dv is v. Let's say you would like to integrate ds. The integral to 1 ds, integrating it is s, or integrating dx. So we get 1 of x. So likewise, okay, this is our function. Okay. So integrating this function, we get a value of this y value, okay, y sine x. So integrating the x, which is x plus c, right? So hence from there we get our y, which is x plus c over sine x. So that is the solution for our first order differential equation. Okay, thank you.